So when we look at this, we want our answer in grams of solution. And I saw quite a few problems getting started with this information. So we think of this as 0.90 grams of salt per 100 grams of solution. And that's what almost every group started with. The problem with that is we want our answer in grams of solution, and here the grams of solution was on the bottom. So the best way is to flip that around. Start with the unit you want on top. 100 grams of solution per 0.90 grams of sodium chloride. Now we'll multiply by our 1.50 grams of sodium chloride. We can only keep 2 sig figs. So my calculator said 166.6666, but I can only keep 2 sig figs, 170 grams of solution. Now, how many grams of water would be used? I could do this a couple of ways, and again, I really have to think about the sig figs here. So 170 grams of solution minus 1.50 grams of sodium chloride. The calculator says 169.1 grams of water. But when I'm subtracting, I have to stop in the tens place. What? So I have to report 170 grams. I have to stop in the tens place. And looks like everyone did this correctly but wasn't thinking about the sig figs. And when you look at that, you're like, yeah, that doesn't seem right because it's like there's nothing being added. But when we're rounding to tens, that's what it comes out to be. Now, how do you really do this? How would you mix up this solution? What you would do is set a beaker on a balance. And then you would weigh your 1.5 grams of salt in there and very carefully add water until the total was 170. So are you really putting in the same amount of water as solution? No, you're not really, but it gets a little weird with sig figs. So you do have to watch that with sig figs. Okay, do you have any questions about how this works? I have my math wrong? Oh. Yeah, I do have my math wrong. But it still rounds to 170, doesn't it? So 170 minus 1.5 is 168.5, which rounds to 170. Oh, and I do have my math wrong. And that's what happens when you're talking and writing. Okay, I have it right in the book, but not here. Okay. So now, when you look at this, you say, okay, how would I prepare this? Well, when we think about preparing things, we think about following instructions. If you said to me, how do I make a cake? And you've never made a cake before, but you've eaten cake and you'd like to make a cake. What do you tell someone when they say, how do I make a cake? What do you tell them? Go to Meijer's and buy one at the bakery. No, that's how do I eat cake? How do I get a cake to eat? Go to Meijer and buy one. Actually, I prefer Walmart's bakery, but anyway, and Sam's Club because I like their whipped frosting too. But how do you make one? Do you just say to them, 3 cups of flour, a teaspoon of baking soda, 2 eggs, sugar? No, you don't just give them a list of ingredients. You give them instructions. So when we want to know how do we prepare solutions, we're going to give someone written instructions, not just a set of ingredients. So how would you prepare? This means that I have to write instructions. We want 125 grams of 15% sucrose solution. So the first step is to calculate the masses that we need. So I know that 15% is 15 grams of sucrose per 100 grams of solution. So 15 grams of sucrose per 100 grams of solution times 125 grams of solution is equal to 18.8 grams of sucrose. So now if I want to know how do I prepare that, well, I figure out how much water do I need also. So 125 grams of solution minus 18.8 grams of sucrose is 106.2 grams of water. So now I know what to put in my solution, but I still don't know how to prepare it. Just like baking the cake, you don't just say flour, sugar, eggs. You have to give instructions. You start off by beating the eggs with the sugar. Then you fold in the flour to your wet mixture, and then you smear it in a pan, and then you bake it, right? You give instructions. So we would say weigh 18.8 grams of sucrose into a 250 milliliter beaker. I want it to be big enough that I have room for stirring. Is there a question? Okay. You're making a cake back there? What's the consensus? Who puts lard in a cake? Only Jason. Pie crust. Lard makes the best pie crust. It does make better pie crust than Crisco and all that other stuff. My sister-in-law makes great pies, and she always uses lard. And now I invite her to holiday meals just so she'll bring the pies, so I don't have to make them. She actually won a pie baking contest in Genesee County. She won the best apple pie in Genesee County a few years ago. So I just bring her in? Yeah, I could call her and order some pies. I'll text her tonight and tell her I was talking about her in class and I need some pies for class. She always brings the pies, and my brother-in-law's name is Raymond, and he loves raspberry pie. It's his favorite. So she always brings cherry, raspberry, pecan, apple, pumpkin, and mincemeat for Thanksgiving, like all those pies. Oh, yeah, it's a pie fest. And whenever she comes in with the raspberry pie, she does it all fancy on her crust and cuts the letter R in so she can identify the difference between raspberry and cherry. And Raymond always says that's his pie because it has his initial on it, which means then the cherry pie is mine because it's got a C on it. Okay, so we're going to weigh this 18.8 grams of sucrose into a beaker. Then we will add water to a total mass of 125 grams. And then we mix it. So percent solutions are pretty easy to make. You just go ahead and weigh things in, and you can weigh them right into the beaker. Now, the only tricky part is when you're adding the water, if you add too much, you're kind of out of luck. So you don't want to just dump water in there. You put it in with a dropper, like one drop at a time till you get to your total mass. Okay? This one's for you to try. So go ahead and do that on your board areas and make sure you write the instructions.